Hi guys. Today we're going to talk about RISC-V RV32i single cycle core with M and C extension. By C, I mean not compress. I mean custom instruction because I've added Mac unit on the core right here. Yeah, right here. So let us jump into it. And by the way, this is on the Lotus same Evolution 3.8. So we are basically emulating the RV32IC custom architecture on this particular software. Its navy nets were routed manually by hand. It was done quite a while ago. It took me some time, but it was very useful because at the end of the day, it teaches you a lot. When you route everything manually, it's very easy to convert this to Verilog and then translate to Verilog from this. Yeah. So nonetheless, what I'm going to do is I'm going to quickly display something. I'll explain the architecture details, but for now, let me quickly explain. Let me quickly run an application on it. Just clear the image. Sorry, the display. Let me load the instruction memory with some instructions. Alright. Then let me load the data with some data memory. Alright, this is the one. And this is just for testing. I'm going to do the same. So this is independent of the whole core. This is totally independent. So we have loaded everything and we are good to go. I'm gonna enable auto take. Alright. It has started running. Okay, let me disable this one. Enable. As you can see, it started printing from left to right, top down. And similarly, let me enable this, and this, and this. Yeah. As you can see, it started printing. Yeah, while this is running, let me quickly go through other things as well. For example, the image that we have right here, that it has to we have to put it in a particular format into the data memory. So this was done using the C code and the MATLAB over here. As you can see, this is the input image and this is the final text file that is generated. Is the input image. Yeah, let me quickly run this as well. So this is the this is the image and this is the input image and this is the text file. Yeah, this is the text file and this is what I just loaded right here in the data memory. And as you can see, we are already seeing the output. Yeah. All right. So apart from this, I'm gonna run. I have some pre-recorded lectures. Not lectures, a video regarding compiler, online compiler. Where is that? So we're going to go everything in details, each and every net of the architecture, and even we're going to use, for now we're going to use online compiler, but later on we're going to install this C cross compiler for RISC-V, and then even we're going to learn how to add, let's say, the instruction memory, the custom hardware, the Mac, how to add its corresponding modification in the compiler as well. Yeah. So this is the compiler. The compiler compiles. This is just an add function and global variable. It just add two numbers and just a plus a. Just returns a plus a. This is its corresponding assembly. Then I just copy paste over here in the assembler, and then get the hex. And the hex can be tested over here in this particular website. For example, FF whatever the instruction I've copied here corresponds to add immediate. Then you can go to the interpreter and run step by step to check to verify the instructions as well. And I've copied and pasted the instructions into text file, and then loaded the instructions into the instruction memory, and then you start running them. Yeah, and about the compiler, yes, we're going to use online compiler for a while. Later on, we're going to use GCC cross compiler, and even you can use QEMU. Yeah, we'll get into it later on in details. Yeah, I think for now, this is what it is. So see you in the next video. Okay, let me quickly explain the architecture quickly before I have two things. I still need to explain you about the software installation and then the architecture in this video. So let me start with the architecture, and then we'll end this video with the installation process. Yeah. So we have the program counter right here. As I mentioned, this is arbitrary to I with M and custom extended. And we have instruction memory right here, and we have stuff here to debug. Right now, as you can see, it's in immediate type instruction. It's executing immediate instruction, so you can see right here. Then we have the opcode decoder right here, and then we have branch comparator, and then we have our 32-bit register, 32-bit 32 registers. Then we have our immediate data extractor. Then we have our ALU. Then the M extension, the custom extension. Then data memory and the IO peripherals. And yeah, we have LCD 7-segment display and the LCD. Let me stop this right here. Yeah. So this is the architecture. Regarding the installation, what we can do is you can go to Logisim. You can just Google it. Logisim RHL 7.9. Okay, I'm using the Red Hat Linux 7.9. You can just Google it right here, and this is the GitHub page for Logisim Evolution. You can go here, then you can download this 2 file. I've already downloaded for you, so yeah, as you can see here, let me go to that location, and let me delete them because I've already downloaded and placed it over here. These are the 2 files which I just downloaded. You can install this way: 1, 2, 3 RPM minus I, I'll just say 3 and X RPM since I've already installed it, showing this, or else you can follow install using snap install. LOGISIM. Wait. Yeah, LOGISIM evolution. Since it's already installed, it's saying, yeah, it's already installed. So, and then as I mentioned, I'm using Red Hat Linux 7.9. As you can see, what is it? Command etc. Then what's okay, yeah. As you can see, I'm using Red Hat 7.9, and then CPU, the x86 24 core, and then yeah. So yeah, these are two ways of installation, using RPM or Snap. And the jar file you can directly run using this jar file. It was not working. For example, let me show you in the older version. Oh, it's the same. Where is that? Where did I cap? Okay, here it is. Terminal. Java minus jar. Yeah, you can launch this way. Yeah, that's all. Okay, so I would say this is one of the best approach, because you can get to know the design architecture net by net, because you're routing it manually. Although it takes a lot of time for one time, it's a very good investment for the first time. Once you're done with this, you can write your own Verilog, and then you can use various open source tools to quickly compile and check and monitor the output. For example, let me quickly. So we're going to use. You can use iVerilator or iVerilog Icarus to compile the Verilog file. Okay, so let me go over there. HTL header, not this one. Git clone. Yep, over here. So we have our design file, the design test, and this is the test bench. So I can just iVerilog test O, then the output file name out ccc, let's say counter underscore tv, then followed by tut counter dot v. Okay, so we have the output file. We can execute like a normal binary file. Dot slash out underscore ccc. Here we go. Similarly, we can use Python verification platform. You can use CocoaTV. Let me quickly demonstrate one of the example over here. Let me open this other file, HTL. Yep, so this is the design. Is it the one? Okay. Yeah, that was the design file. And let us go to the test. This is the byte test bands, and we can see we are incorporating the DUT over here, right? Let us go to this location, copy path, paste, see over here. We don't want this. Okay, what do we have? Let's do make clean. All right, then make all. Let's make what it's gonna do is it's gonna generate this VCD file, and yeah, let's just this particular header. All right, let's pause. Let's got this. We can check the waveform. GTK Wave. GTK Wave is another open source tools to visualize the waveform. Dump.vcd. So we have the adder over here. These are the signals. Let me just bring up over here and then the effect. So let me change this to decimal. Yeah. So now we have an adder over here. 4 plus 610, 15 plus 318. Blah, blah. So yeah. So once we have this architecture and understood, then we can write the Verilog. And one more thing that I would like to mention is the dataset, the ISA specification and description. For that, we can go to just Google RISCV. You can go to the main website and then technical. Okay, community and learning. Nope, where was that? Specifications. Then we can download this 2024 volume 1 unprivileged specification PDF. So this is where we can see all the ISA description. For example, I was implementing RV32i base, and on top of that I was adding extensions such as M and some custom instruction. So all those details can be found in this document. Yeah, so let's follow up with the demonstration.